Good evening, everybody. Can you see me?
Good
Can
evening,
you?
sir.
Yeah. Good evening.
Good evening, sir.
Good evening. So let me present the screen. Can you see the presentation? I hope so.
Yes, sir.
Yeah. Good evening, everybody. So today's is our last lecture. I am Venkat Subaredi, research scholar at University of Hyderabad. So I'm here to teach some problems from previous year assignment. Here is the assignment problems. The first one is consider the following linear system. Given a linear system Ax equal to b, then the Krylov matrix of second order of A and B is given by. Can anybody tell me what it is? The Krylov's matrix of second order. Can somebody?
So it's B.
Yes.
It is L B comma A B.
Yes. B comma A B. When we
B.
read the
A.
yes,
Oh,
when we
okay.
read the columns of the vectors in a matrix form, that is nothing but the Krylov matrix of second order. This is denoted as K2 of A comma B. It is what it is asked. So there is nothing to do much. But anyway, let me do this. So given Ax equal to B, given where A equal to 1 minus 3 minus 2 1 1 4 5 minus 1 1. This you can check. Actually I have written on a paper, so I'm just writing directly so that we can save the time. 401. So this is the system that you can check. 401. Okay, so we just have to calculate the matrix AB. That nothing but 1 minus 3 minus 2 1 1 4 5 minus 1 1 into 401. This is nothing but we'll get 4 minus 2 2, 4 plus 4 8, 120 plus 1 21. So this is nothing but AB. So the Krylov's matrix of second order K2 of A comma B, it is nothing but B comma AB. This is the first column we have to write. AB we have to write in second column. So by writing that we get this is 401. AB is 2821. This is the problem. Let me show you the options. So 2 8 21, option C is the correct. Anybody have any doubt in this problem?
No.
Okay, thank you. The second problem is in the conjugate gradient method. The the jth approximation xj of the solution vector x of system x ax equal to b belongs to the subspace. Can anybody answer? This is a direct problem from your notes. Does anybody know this?
Fourth option, sir. Is it fourth option?
Yes, yes. There is nothing. There is a direct explanation for this that you can check in the class notes. So the jth approximation is nothing but x naught plus kj of a comma r naught. Here r naught is nothing but b minus ax naught. So that this is a direct problem, b minus ax naught. This you can check in your class notes, it is there why it is. Okay. So the third problem is consider the following linear system. Given a system ax equal to b, if we apply conjugate gradient method, again the same method, with initial solution x 0 0 0, that is nothing but x naught. It is given that x naught equal to 0. Then the step length x1 after first iteration is given as, it is asked to the value of alpha 1. Can anybody tell me the formula for alpha 1?
That is
By
R1 transpose R1 divided by D1 transpose A D1.
yes,
First, we need to find out R0, D0, everything, no, sir?
yes, we have to calculate conjugate gradient method. So by this method we have alpha 1 equal to R1 transpose into R1 divided by D1 transpose into D1 only, AD1.
AD1.
Yes, but of course firstly we have to calculate the value of R1 and D1. So let me write the formulas for R1 and D1. So we have the value of R1 equal to R0 minus alpha naught.
Alpha naught AD naught.
Yes, here R0 is equal to B minus AX naught. X naught is given in the question, that is 0, and B and A are also given in the problem, and this is nothing but D naught also. So from this we can get the value of, we have to calculate the value of alpha naught also for this to calculate the value of R1, and here alpha naught is equal to R0 transpose into R0 divided by, similar as alpha 1, this is D naught transpose into AD naught. So we have the value of R0 and D naught. So from this we can calculate the value of R1. But to calculate the denominator here, we have to calculate the value of D1 firstly. So the value of the formula for D1 is R1 plus beta naught D naught. Here we have the value of R1 and D naught. We don't have the value of B naught. For that also we have a formula, that is nothing but B naught equal to this inner product of R1 comma R1
R1 divided
yes,
by R0
divided by inner product of R0
R0
comma,
R0
this can be written as R1 transpose
R1
into R1 divided by
R0
R0 transpose R0. So here we have the values. If when we take in A and B and x0, then we can calculate one by one. So firstly we will calculate the value of R1. For that we have to calculate the value of alpha naught firstly, because we have the value of, we can find the value of R0 and D0, both are same of course. So to calculate the value of R0, firstly we have to calculate the value of R0 again. So firstly let me calculate the value of R0. R0 is nothing but B minus, okay, firstly let me write the value of A and B so that we don't scroll again and again. So given A equal to, this is nothing but from the problem only, 3 0 1 0 2 2 1 2 3 comma B equal to 1 0 0. This you can check. Let me show you the problem. Yeah, so that you can see, of course the matrix is symmetric here, that you can check easily, but we don't have any use of that. Of course to apply this method matrix A has to be symmetric. So the value of alpha naught, firstly we have to calculate the value of R0 equal to B minus AX naught, and X naught is given in the problem as 0, so it remains as B, that is nothing but 1 0 0, and this is also nothing but D naught also. So now we will calculate the value of alpha naught. Alpha naught is nothing but R0 transpose into R0. So R0 transpose into R0 divided by D0 transpose into AD0. This is nothing but 1 divided by, this is inner product of D0 transpose. Firstly you will calculate the value of AD0, that is 3 0 1. This you can check easily. This is d naught is 1 0 0. So this results as 1 divided by 3. This is alpha naught value. From this we will calculate r1. R1 is equal to r naught minus alpha naught ad naught. R1 equal to r naught minus alpha naught ad naught. Is it right? Yeah. So we have the value of r naught as 100 minus alpha naught is 1 by 3 and A is the given matrix 301 022 1 2 3 into d naught is again 100. By doing this we get 100 minus 1 by 3 times this is 301. So in result we get 0 0 and this is minus 1 by 3. This is the value of r1. So from this we can get the value of numerator in this formula. Of course we have to calculate the value of denominator. For that we have to calculate the value of d1. So firstly we have to calculate b naught here, and then that's it. If we calculate the value of b naught, from that we can calculate the value of d1. We have everything. So the value of b naught is inner product of r1 comma r1. So b naught is equal to r1 comma r1 divided by r naught comma r naught. This is equal to inner product of r1. R1 is this matrix only. So this I'm writing directly. This will get 1 by 9 divided by inner product of r naught comma r naught. R naught is nothing but 100. So we get this as 1. This is equal to 1 by 9. This is the value of b naught. From this we calculate the value of d1. d1 is equal to r1 plus beta naught d naught. So r1 plus beta naught d naught. So r1 we have the value of r1 as 0 0 minus 1 by 3 plus 1 by 9 times d naught is 100. So this we get as 1 divided by 9 0 and minus 1 by 3. So now we have the value of r1 and d1. So we can calculate the value of alpha 1. So alpha 1 is equal to inner product of r1. R1 is 0 0 minus 1 by 3 0 comma 0 comma minus 1 by 3 a into this vector again. So we will get what is a times this matrix. A is 301, so we will get minus 1 by 3 2 and then okay, let me write one more step so that it will be clear. AR1 is equal to 301 022 123 into R1. R1 is 00 minus 1 by 3. This result as minus 1 by 3 minus 2 by 3 minus 1. Similarly, AD1 301 022 123 into the vector d1 1 by 9 0 minus 1 by 3. So this result, this is 1 by 3 minus 1 by 3, so 0. This is minus 2 by 3 directly. This is 1 by 9 minus 1 minus 8 by 9. So now we can calculate the value of alpha 1. Alpha 1 equal to inner product of r1 is 0 0 minus 1 by 3 comma minus 1 by 3 comma minus 2 by 3 comma minus 1 divided by d1. In product of d1 is 0 minus 2 by 3 comma minus 8 by 9 into ad1 is 0 minus, sorry, this is d1. Okay, so this is minus 2 by 3 minus, I'm writing wrong, this is 1 by 9, 0 minus 1 by 3. So what it result, this is 1 by 3 divided by these two will become 0 and the last one will become 8 divided by 27. So it will become 9 divided by 8. Is it okay, or is there any mistake? Yes, anybody? Is it clear, or anybody found any mistake? Yes.
It's correct, no, sir.
Yeah, just check the calculations. This is the method, maybe some calculation error can be there.
We will do it, sir. We will check again.
Yeah.
It's okay.
Yeah, so is there any doubt in this process, in this method?
No, sir.
Yeah,
Let us
if you
go.
know the formulas for each this, for these values r1 alpha naught d1 and b naught, you can calculate this simply. I think there is one problem in your current assignment also similar to this problem. You can just check that. Okay, so coming to the fourth problem. For solving a system Ax equal to b in the SOR preconditioning, we choose the preconditioning matrix M as. Yeah, can anybody guess this? This is given SOR preconditioning.
Is it third or fourth, sir?
It is fourth. Actually, the formula is 1 divided by W dW plus L. Sorry, D plus LW. So
Okay.
it will become D by W plus L. So fourth option is the correct. And for Jacobi we have different one, and for Gauss-Seidel preconditioning we
Gauss-Seidel,
have,
yeah.
we have another.
Mm.
So here is one more important problem. This we have to do some calculations. So given a be a positive matrix, so we have A greater than 0 and rho of A is the spectral radius of A. Then which of the following is not true? We have to check the incorrect option. So whenever we have A is greater than 0, we have rho of A also greater than 0. From that we can say A divided by rho of A is greater than 0. Let me write this. So the fifth problem, A is given 3 cross 3, comma A is greater than 0 and rho of A is rho of A is equal to spectral radius. So option A says that we have A is greater than 0, and since A is positive, so rho of A is also greater than 0. So from this we can say A divided by rho of A is greater than 0.
Okay.
So B option is, so if U greater than V greater than 0, then AU is greater than AB. This is also
True.
true.
True. Property of positive matrix.
Yes. U greater than 0, U greater than V greater than 0. It implies AU is greater than AB is greater than 0. This is a direct property. This you can check in our class notes. And here is the main option, third option. You have to be careful about this. So null space n of a minus rho of a into I is a two-dimensional space. That is, let me explain about this.
No, it is one dimensional.
Yes,
Because it is arithmetic mean is equal to geometrical mean, right?
yes.
Hmm.
So okay. Is two-dimensional. Two-dimensional or not? This we have to check. But give whenever a is greater than 0, we have that algebraic multiplicity of rho of a is equal to geometric multiplicity of rho of a, where rho of a is greater that spectral radius. This we have that is equal to 1. That implies here geometric multiplicity is nothing but the null space of a minus rho of a times I. The dimension of this space is equal to dimension of this space, and this is we have that is equal to 1. So we can say n of a minus rho of a times I generates by single vector. So the option C is the wrong option because they are saying it is generated by two vectors.
Sir, I have a doubt, sir.
Yes, please.
Will the eigenvalues of a positive matrix be negative also, not the spectral radius? Other eigenvalues of a positive matrix, can it be negative also?
Yes, it can be negative.
And the lecture says 0 cannot be the eigenvalue of a positive matrix. Why, sir? 0 cannot be the one of the eigenvalue of the positive matrix. Why 0 cannot be an eigenvalue?
0 cannot be an eigenvalue.
Eigenvalue of a positive matrix.
Okay, this I have to think. If a is greater than 0, then eigenvalue cannot be 0.
Eigenvalue can be positive or negative. Only the spectral radius is positive.
Yes, spectral radius is positive, but you are saying eigenvalue cannot be 0.
Yeah, that is what it says, sir. In the lecture, he says that the eigenvalue of a positive matrix is not equal to 0 at all.
Okay.
Now, one more question is, can it have negative eigenvalues also?
Yeah, it can have negative values that
Hmm.
we can see that actually in this assignment also for some one matrix there are we can get some eigenvalue that negative eigenvalues. I think for seventh or eighth problem. For seventh problem, this problem, so that we will see.
Hmm.
For 0 we have to I have to think.
Okay, sir. You
Yeah,
later you tell me.
yeah, okay. So this is the wrong option. So actually this is the correct option actually, because the statement is wrong. Of course we have to check the
Sir,
fourth option also.
excuse me, sir.
Yes, please.
Seen some question
Yes,
because as I have seen that lecture, positive definite symmetric matrix has strictly positive eigenvalues.
yes,
Ma'am was asking now why we are not having zero
yeah, see,
eigenvalue.
If it has only positive eigenvalues, I get the answer for my question. Zero cannot be an eigenvalue. No, my question is whether it has only positive eigenvalue. That is not mentioned in the lecture, ma'am. They say the spectral radius belongs to the spectrum of positive matrix,
Okay.
but they don't say that it has only positive eigenvalues.
Okay.
Uh,
I think 0 is also possible. Okay, we'll see that again.
mm,
I think for that matrix 0 is also possible. For this matrix, okay, we'll see that later. So the fourth option here we have to check about this also. So let me explain why it is. The fourth option is if every row sum of a is equal to rho, then rho of a is equal to rho. Then that means the spectral radius is nothing but if every row sum is equal to some fixed quantity, then that spectral radius has to be equal to that row sum quantity. That it says if every row sum is equal to rho, then rho of a is equal to row. This we have to prove. So let me take a matrix A, given matrix. I'm not taking, of course, this is some 3 cross 3 matrix. So I'm taking E as the vector 1 1 1. Is it given a 3 cross 3 matrix or fixed n cross n? It is 3 cross 3. Okay, so I'm just taking E equal to 1 1 1. Can anybody say what is A dot E?
What is E, sir?
E is a vector.
Just one random vector.
Yeah, this is the vector. All elements are 1. Of course, this is greater than 0. Can anybody tell what is AE? Can I say this is equal to
Addition of the elements of the row.
yes, A11,
When you
A1,
multiply, yeah.
A13, A21 plus A22 plus A23, and A31 plus A32 plus A33. This is 3 cross 1 matrix, not 3 cross 3 matrix. This is 3 cross 1, just a vector. So I can write this as row times E, because we have that every row sum is equal to row. So we have that A11 plus A12 plus A13 equal to row. Similarly, the remaining rows also. Is it okay?
Okay, sir.
So we have A equal to row E, and we have that row of A is equal to spectral radius. We have a theorem that there exist no non-negative eigenvectors other than Perron vector and its multiplies and its positive multiplities. This is a theorem that you can find from class notes. That means that every vector that implies because we have shown that here E is the eigenvector for the corresponding row. I mean row is eigenvalue here. So we can say E is equal to some constant times the eigenvector corresponding to row of A. What is that? How it is denoted by that row of eigenvector corresponding to row of A? P. Okay, let me write. Let P be the Perron vector. What it says is any vector, any eigenvector, it should be either a P or it should be a positive multiple of P. That's what the theorem states. So, but here we have that E is an eigenvector, so it should be either equal to P or a positive multiple of P. That implies that means either it should be E equal to AP, where A is greater than 0 for some fixed quantity A. So we will use this, and P is Perron vector. That means that is A times P equal to row of A times P, because it is a Perron vector for the corresponding eigenvalue row of A. So we use this here. So from this we can say A times E. Instead of A I am writing A times capital P. This we can write from that above equation. We can say P times E. Sorry, this is row times E. Don't confuse, this is P and this is row. So this I can write A times capital A P, and this is equal to row E. That implies A times, this is we have row of A times P, because we have P is the Perron vector for the corresponding eigenvalue row of A. So this is nothing but row of E. A times
P.
A times row of A times P equal to, this is rho times E is nothing but A times P. So from this we can say A times rho of A minus A times rho into P equal to 0, and here P is the parent vector, so P should not be equal to 0, and the left side, this quantity within the bracket is a fixed quantity, fixed positive, sorry, need not be positive, a fixed real quantity. It is, yeah, correct. So that implies we can see A times rho of A minus A times rho equal to 0, but we have that A is positive, so rho of A has to be equal to rho only. That implies if every row sum is equal to some fixed quantity rho, then that row has to be equal to the parent vector rho of A. Is it clear? Just I am using the main
Sir,
theorem.
this theorem which you said now,
Yes.
we have a question based on this
Okay.
in our assignment 12 something we get, where the sum of all the three rows is 12, and 12 is the parent value,
Parent eigenvalue. Yeah.
eigenvalue. Yeah.
Yeah. This is one important theorem that you can see. So the correct option is C. That is wrong statement. Is there doubt in this problem? Okay, if not, I will proceed with the next problem. So sixth problem, the parent root and the parent vector of the matrix A are given as. This you can check. Just calculating the eigenvector and eigenvalues. First, of course, for which eigenvalue we have to calculate the eigenvector, that you should know.
Sir,
Yes.
sir, actually, in the assignment, we have one question finding the parent root and the parent root and parent vector of
Okay.
some matrix they have given, sir. But
Okay.
parent root and parent vector is defined only for positive matrix, right?
Yes.
But it is a non-negative matrix which they have given. It contains zero also as elements. But the video says it parent root and parent vector is only for positive matrix. But there they have given a negative matrix they have given,
Okay.
meaning it contains zero also.
Maybe one thing, in the class notes they said it should be greater than 0, right?
Positive.
Yes. All the elements has
All
to
the
be
elements should be strictly greater than zero,
yeah.
they say.
Maybe
But the assignment question has a matrix which contains zero also. And they have asked us to find out parent root and parent vector.
maybe the problem is wrong. Okay. That we can post in that discussion forum. The NOC NPTEL team will solve that. Okay. So here the given problem, sixth problem. What is the matrix that I have to check? So the sixth problem, the matrix is 6 2 8 3 1 4 3 2 3. Okay. A equal to 6 2 8 3 1 4 3 2 3. For this we have to check the eigenvalues and eigenvector. So let me calculate the characteristic polynomial a minus lambda I. This is equal to 6 minus x 2 8 3 1 minus x 4 3 2 3 minus x. So the determinant is 6 minus x times 1 minus x into 3 minus x minus 8 minus 2 times, removing this row and column, we get 9 minus 3x minus 12 plus 8 times 6 minus 3 plus 3x. Yeah. This results as 6 minus x times 3 minus 4x plus x square minus 8 minus 2 times minus 3x minus 3 plus 8 times 3x plus 3. Okay, we can keep this as it is, so that we can take the common element as, there should be no. Okay, so this results as 18 minus 24x plus 6x square minus 48 minus 3x plus 4x square minus x cube plus 8x plus 6x plus 6 plus 24x plus 24. In total it results as
minus
minus
x
x
cube
cube, yeah, x
plus
square we have,
10x square
yes, plus 10x square and
minus 11x
minus
plus
24,
11x.
yeah, plus 24 gets cancelled, minus 11x, constant term 20, 30, 48.
Minus 24 plus 18 plus 24 minus 48.
What? Yes, please. Yes.
It is 6x square
40
minus
cancel.
40.
What?
Actually cancel.
40 cancel.
Sorry, I cannot hear you. Your voice is breaking.
18 minus 48 plus 24. 48 minus 48 plus 24, it is minus 24, then minus 8 plus 18, sir. We will do then minus 6, I think. Am I wrong?
Yeah, please tell me the direct this what it can be written as.
The determinant is 18 minus 48 plus 24 plus 6. Is there anything left?
Okay, what are the eigenvalues? So eigenvalues are
1 is 1, no? X is equal to 1. 1.
okay.
No,
If we write
no.
one, no.
No.
Just check minus one.
Sir, can you scroll the ones? I want to see the matrix. Can I see?
Yeah, please.
See, wait a second. 6, 2, 8, 3, 1, 4, 3, 2, 3. Thank you, sir.
Yeah, 1 minute. Some calculation error is there, I think.
What, that is why I'm saying, sir, the constant values
Okay.
is correct.
Sir, x plus 1 is one factor, sir. From these last two terms you see, you can take x plus 1 outside. This, when you factorize this quadratic factor in the first term, you get
No.
x plus 1 as a factor, which can be taken out.
Wait.
You can simplify instead of multiplying 6 minus x with the quadratic factor. Factorize the first term, second, and third, you get x plus 1 as a
No.
factor.
No. Actually, here we have 24, 6, 30, 48, and we have the here minus 48. So all these terms will get cancelled. I missed that minus 48, so we'll remain with this only. So we'll get that x times minus x square plus 10x minus 11.
See, x is equal to x plus
Yeah.
1 is a factor.
Yes. X plus 1 into x minus 11. So the x minus 10.
Oh,
So
then
the
10 is the parent root.
sorry, 11, I think. Okay, this is 11. So eigenvalues are 0, minus 1, 11. And
See, sir, for this,
yes,
this is a positive matrix, no?
yes,
Eigenvalue 1 negative, 1 0, we are getting.
yes, all are possible.
But in that lecture, he says 0 is not an eigenvalue of a positive matrix.
0 can be eigenvalue. Okay.
Okay.
From this, now you got the confirmation. Parent value equal to 11. For this corresponding eigenvalue, we have to calculate the eigenvector. That eigenvector is called as Perron vector. So we have to calculate, we have to solve the equation a minus 11i times x equal to 0. A minus 11i is nothing but 6 minus 11 minus 5, 2, 8, 3, 1 minus 11, this is 10, minus 10, 4, 3, 2, 3 minus 11, minus 8, into x1, x2, x3. By solving these equations, we get the value of the run vector.
So solving this matrix, no sir, getting 0, 0, 0 as one, we should get 0, 0, 0, right? One row.
Yes.
That is very difficult, sir. In the question given also, we are not at all getting 0, 0, 0.
Okay. So, does anybody solve this? Or can anybody solve this? Just solving the equations. Can you solve? Or you want me to solve? What is the time? Time is getting
We are
over. Okay. Solve the system.
Sir,
Yes.
we will do this.
Okay. So this is about sixth problem. Yeah. So
Or what we can do is we can just verify, sir. The only two vectors we should check, no?
yes,
That we can
among
do.
these two we can we can check for the eigenvalue 11. Yes.
Yeah.
Okay. The seventh problem is also similar. Then the total number of eigenvalues which lies on the spectral circle of A. Yeah. Seventh problem. So the given matrix is 0, 3, 0, 1, 0, 2, 0, 3, 0. Zero, 3, 0, 1, 0, 2, 0, 3, 0. Yeah. Can anybody guess what is one eigenvalue? Can guess any one of eigenvalue?
Is it 0, sir?
Yeah, okay, 0. How?
This is.
Yeah, if you check the determinant, if it is 0, you can say one eigenvalue is 0. So actually the determinant is 0 here, because the first element here it is 0 and the third element is also 0. For the middle element 3, we have to check that determinant, so that is also 0. So determinant is
Yes,
0.
determinant is 0.
Okay. Cayley-Milton theorem.
Yeah,
Oh, A minus lambda is equal to 0.
yeah. So we can say one eigenvalue is 0. And can you say any other eigenvalues? Do you remember we solved one problem by taking E equal to 1, 1, 1 just now? For this eigenvalue, sorry, for this vector, can we say
3.
yeah, because
Oh,
the row
all
sum
the
of
three
each row
rows
is
same, constant.
yeah. So I can say 3 as eigenvalue. And can you guess the other eigenvalue? Because the trace should be 0, as the sum of the diagonals is 0. What is it? Should be the other eigenvalue?
Minus 3.
Minus 3.
Yeah. Without solving the equation characteristic polynomial, you can just guess by this matrix. This is how it is. So row of A here it is 3, and the number of elements. The question is about the number of eigenvalues lies on the spectral circle. So the number of eigenvalues lies on the spectral circle is 2, that you can check. 3 and minus 3 both lies on the spectral circle. When we take the circle with center 0 and radius
3 units.
radius as row of A that equal to 3. This is the radius. Then you can see here we can get minus 3, and here this point is 3. 2 eigenvalues lies on the spectral circle. Is it clear?
Sir, spectral circle meaning
Yes.
the radius of the circle should be the this one. What is that? Maximum eigenvalue.
Maximum I know.
Yes,
Is
maximum
it
of
maximum eigenvalue?
no. Radius that what is this spectral radius? Spectral radius is
Spectral
nothing
radius
but
meaning maximum only, no?
yeah maximum of modulus of each eigenvalue.
Modulus.
Yes. Yeah.
Sir, then if it is suppose say 0 plus
Okay.
or minus 1 plus or minus 2
Okay.
eigenvalues,
Okay.
then the spectral circle will be circle with center 0 and radius 2 units, no?
Yes, that one.
Huh?
That's yes, correct.
But in the video they say with radius 1, sir.
How it is?
Yeah, plus or
The,
minus 1 plus or minus 2 last video, sir. Class video plus or minus 1 plus or minus 2.
no, it should be spectral radius should be 2 that you can check easily maximum of
Spectral
modulus.
circle meaning radius should be the spectral radius.
Yes,
Okay.
with center 0. Yes.
Okay.
Yeah. Is there any doubt in this problem still? Okay. If not, I'll proceed with the eighth problem. So for this we have the answer is 2. That is option C. So the eighth problem is the matrix A. Given a matrix, it is asking about reducible and primitive. Yeah. Can anybody say how to check the reducible and irreducible?
Strongly connected, irreducible matrix.
Yes. We have to check whether the matrix is strongly connected or not. For that we have to draw the graphs. Graph means there is not a big graph, just a small graph. That let me explain. Based on that elements in the matrix, we can draw the graph. So the eighth problem is given A equal to 504 109 060. This is the given matrix. For this matrix we have to the graph that you can check. It is a 3 cross 3 matrix. So let me consider 3 nodes. We have A is irreducible if and only if A is strongly connected. So we are checking the connectedness, strongly connected or not. For this strongly connected, we have to check the graph of the matrix A is, for the graph of the matrix A is strongly connected. Strongly connected means we have to find a directed path from each node. That means let me consider, because it is 3 cross 3 matrix, I am taking 3 nodes n1, n2, n3.
I think it is strongly
Or-
connected, sir.
Yes. Let are 3 nodes. So we have to draw the graph n1. Firstly let's write the 3 nodes as like this and write a line in between these 3 nodes as like this. Now we have to give the directions from n1 to n2. How it should we have to give the directions is, there should be a direction from ni to nj if aij is not equal to 0. So firstly we have to check the value of a12. We have that a12 is 0 here, so there should not be a direction from here, there should not be here. So let me leave it is as it is. We have to check a13. So a13 is 4, that is non-zero, so we can draw a direction from n1 to n3. Because a13 is non-zero, there should be a direction from n1 to n3. Similarly we have to check the other elements also. In the next row we have a21 is non-zero, so there should be one direction from n2 to n1. Similarly from 2 to 3, from 2 to 3 there should be one direction. And from the third row we can say from 3 to 2 there should be one direction. Now this is the graph of the given matrix. From this we have to check what strongly connected means. connected means for any ni comma nj there should be a directed path between ni and nj. That means we have to find a path from n1 to n2, n1 to n3, n2 to n3 and the reverse also.
Sir,
Yes, n2
I
to n.
and J should be different, right?
Yes,
Means self loop is not required.
yes. No,
I
we
to
don't.
I is not required
Yes, yes, we don't
for
need that.
strongly connected.
Yes, n3 to n1 and n3 to n2. This we have to check all these directions. So from the given graph we can see n1 to n2. So for given n1 to n2 we can check that through n3 we can come to n2. So
one path from between two nodes. That means strongly connected means
yes,
there is at least one path from any two nodes.
yes, directed path. Yes.
Connected.
So from for in
Yeah,
between
directed
n1
path.
and n2,
Okay.
in between n1 and n2 we can check there is one path, and in between n1 and n3 there is a direct path. Similarly from n2 to n3 we have one direct path that we can check. n2 to n3, this n2 to n3 there is both side path from n2 to n3 and n3 to n2 also. Similarly for n2 to n1 there is path direct. From n3 to n1 we have through n2 directed path. Similarly from n3 to n2. So we can say the graph is strongly connected. So graph of A. Connected. So we can say A is irreducible. Is it clear? Of course we have to check the primitivity also. Is it clear about irreducible from this graph?
Clear, sir. Clear.
Yeah. Thank you. So we have one more theorem about to check for primitivity.
Only one eigenvalue on the spectral circle.
Yeah. So A has to be, if A is greater than 0 plus A is irreducible plus at least one non-zero non-zero element in the diagonal.
Sir, this is only sufficient condition, sir. Sometimes it will not be irreducible, yet it will be primitive. This is only sufficient condition.
Okay.
Primitivity, I think you have to find out by finding out the eigenvalues only.
Okay.
You can check.
Okay. Sorry for that. Okay.
Because this doesn't hold good for the question which is given to us only.
This is necessary or sufficient?
It is sufficient.
Okay. If you check this, sufficient means you can just check enough to check this one. Actually, if it is necessary, we cannot say that if this happens then A is primitive. If it is sufficient, it is enough just to check primitive in this. Is it clear? If sufficient means just this is the minimum condition. If it is false, then we can say A is primitive.
Oh.
Suppose we have condition A, sorry, let me say condition P and condition Q. Necessary means P implies Q. P implies Q. Sufficient means Q implies P. Is it okay?
Okay, sir.
Yeah. So sufficient means it is a minimal condition. If this happens, then we can say A is primitive. Okay. So we have A is greater than 0 and A is irreducible also. And from the given matrix, we can say there is one non-zero positive element in the diagonal 5. So we can say A is primitive. Therefore, A is primitive. Is it clear?
Yes.
Okay. So the correct option is irreducible and primitive. Option C is correct. So the ninth problem. Let A belongs to R n cross n given a square matrix have a right polar decomposition, that is A equal to UP, where you can say the columns of U are orthogonal and P is positive semi definite. Then given lambda I of A and sigma I of A are eigenvalues and sigma values of A, then each of the following is necessarily true. Can anybody guess what is the answer?
Singular value should be lesser than. I
Okay.
can't see.
Okay, let me solve this. Actually, those has to be equal. Let me prove that why it is. So given the right polar decomposition, A equal to UP. So can we write A as SVD, that singular decomposition?
Yes, sir.
So we can write A equal to USV transpose. Let me write this as US so that we don't misunderstand for the notation this U and this U. Just the US is nothing but a just notation. And where S is diagonal matrix,
Containing singular values.
yeah, with singular values as diagonal elements. Singular values as diagonal elements. And V U S comma V are orthogonal. Sorry, orthonormal.
Yes.
Yeah, orthogonal and orthonormal also. So that means US into US transpose equal to identity and V into V transpose also equal to identity. Yeah. So let me write A as US S V transpose. So I can just include I here because we have I is nothing but identity, so we can include that here. Instead of I can write it as V into V transpose. V into V transpose, yes, V transpose. Or we can write V transpose into V also. Is it okay? Because we can use this as, because we have V and V transpose are orthogonal, so we can think of this as a diagonal matrix, diagonalizable matrix. Is it okay? Okay. This is V transpose. So this I can write as, let me call this as U times P, where P equal to Vs V transpose. And because V is orthogonal, so I can write Vs V inverse. So from this, what you can say about P?
Is it positive semi-definite?
Yes, yes, of course, that has to be happen. From this you can
The
say
P and S are similar matrices.
yes. So P and S are similar. So what can you say about the eigenvalues of P?
positive,
Okay.
greater than or equal to 0.
Okay, can you say something about related to this?
Eigenvalues of S also.
Yes, eigenvalues of,
Similar matrices have same eigenvalues, sir.
yes. So this is equal to eigenvalues of S. So eigenvalues of S, what are the eigenvalues of S? Can you relate this to some eigenvalue, something related to A?
Value of A.
Yeah. Is it clear? This, because actually I have already written this singular values as diagonal elements. No, not that property. From this property you can say the diagonal elements of S are the singular values of A. Is it clear? So from this we can say eigenvalues of A are singular values, sorry, eigenvalues of P equal to singular values of A. So eigenvalues of P, that is nothing but lambda I of P equal to singular values of A, sigma I of A. These are done, these notations are given in the problem. So the third option is correct. Is it clear?
Okay, sir, correct.
Okay, sir. Okay.
Yes. The 10th problem. For this there is a lengthy calculation that we'll see. Time is
Sir,
over.
it is very, very lengthy, sir. We also have a question how to solve it, sir. Really very difficult, sir. I took 2 hours, still I didn't get proper answer. Huh?
Because when the root of the
So we cannot.
characteristic polynomial is not
Characteristic polynomial, then solving the characteristic polynomial.
Yes,
So
actually
difficult.
there is no other option. We have to calculate this. There is no shortcut method
But
for
in
this.
exam, however, calculate so lengthy question.
Sir,
Okay,
at least you give us the steps, sir.
okay, I'll give
Just
that
tell us the
steps.
steps again.
Okay,
The
if you
steps followed.
okay, if you cannot calculate, I can give you some hint, but I don't know whether it will work or not. So when you write A equal to UP, what is the value of, what can be the condition for U and P? Can you tell me?
You one
Under
should
Yeah.
root
be
of A transpose A.
No,
A
I mean
transpose root.
U and P. What are the
It's a
conditions for
matrix
U? Yeah,
One
columns.
should be column
Columns are,
orthogonal,
yeah,
column orthogonal.
and
and
for
this
Orthogonal.
is
and for P,
semi-positive definite.
yeah.
Semi positive.
If you check from the options that you can get. If P is, it is asked the matrix P. If you check the options, for which option it is positive semi-definite, then you can get.
Oh, we should find out the
That
determinants.
is the way
Okay.
only.
Yeah.
Early.
Oh, the three determinants we should find out.
Yes, yes, right.
Okay. Oh,
But
should be 0 or positive.
yeah, but it can be greater than 0.
Uh, or equal to 0 also.
Or
Yeah,
0.
yeah. But
Okay.
can you say it is unique? P, this P is unique. When can you
Yeah.
say this is unique?
Yes, sir.
Is it always unique? Are there any? There
There
is
is some
any? Yes.
condition given for it to be unique.
Yeah.
Okay.
Unique, sir.
Always.
Always.
Okay.
One condition is there, sir. They have mentioned it in the lecture.
Okay. But but here it can be, suppose for option B, it can be for this matrix it can be greater than 0. I mean it can be that semi positive definite, but it need not be equal to that, it need not satisfy the condition A equal to UP. For that you have to check. Suppose you get for option C and D, you get it is, both are positive semi definites. Then what you have to check, that you can check U equal to AP inverse. For this corresponding to U, you have to check the columns are orthogonal or not. If this, for this U the columns are orthogonal, then you can say the option C is correct.
Okay, okay.
If
Okay,
not
sir.
this, then the other option is the correct.
Okay, sir.
This is one shortcut method from the options. Of course we have to, sometimes we may not get the option by checking the options.
Directly we have not solved this problem.
Yeah,
Okay.
that is a lengthy problem. This is one.
Okay.
Okay, but anyway, let me.
Quite lengthy. In assignment problem is quite lengthy.
Sir, sir,
Yes.
there's actually in that lecture that
Yeah.
they have given one vector, sir. Eigenvalues are calculated and eigenvector for one that parent root. They
Yes.
have put something, but we are I was not getting that at all. They just write this is the parent vector for this corresponding y, but I'm not getting that at all.
Okay.
What to do?
Parent vector, you will take it that the maximum eigen
Yeah, but
corresponding
I couldn't
eigenvector
find
in
out that
the
vector at all, sir. The vector which they have given,
Huh.
I was not getting only.
You mean for the matrix 2 2 1
नहीं
1?
मैम आ जाएगा
No,
आ
no, no,
जाएगा
7 2
I got
3
it
1 8 3 1 2 3. Not assignment question. The lecture.
okay okay
It's a
okay
lecture
lecture
video, sir.
lecture I
Okay, then let me. You just please that post in discussion forum. I will
Yeah,
see
yeah.
that. I
Okay,
do.
sir.
Oh, okay. Okay. Anyway, let me solve this problem quickly. The 10th problem in that lengthy method. You want me to solve or okay?
Sir,
Anyway, I
one
have to
more.
solve. Yes, please.
Sir, how can we access these your video lecture on YouTube? Can we find there is a way? Is
Yes,
there any
there.
way?
Yes, there is a way. Okay.
How we get, sir?
Yeah. Let me tell you. So when you open that the page website, can when you open you can see the that assignment 1, assignment 2. Sorry,
Yes.
assignment or lecture. Lecture 1.
Lecture one. Yes, yes,
Yeah.
sir.
Lecture 2 and so on.
Mm-hmm.
You can see up to 8. In down to that there is one. What is that? Something is there. I think the last option. I don't remember
One
what it
second.
is.
I just open. I can open.
The last option. Can you tell me what it is?
Yes, sir. Just
If you open that link.
solution of the week. Solution
Yeah.
of for the week.
Yes.
Download videos. Okay.
Okay.
Download.
In that option there will be one more link. I think.
MP MP4 फॉर्मेट है वीकली फीडबैक टेस्ट टेक्स्ट ट्रांसक्रिप्ट बुक्स ओपन सॉल्विंग सेशन
problem solving session
Yes. Yes. Problem solving session.
sir in problem solving session we will get your all videos
Yes. There are. The option. The
okay
last
yes
option is
yes
problem
yes
solving
there,
session.
there are link YouTube link I
Yeah.
yes I get it. Okay.
If you click on this, there is one link. When you open, you can get one PDF, one that sheet. There we have the links for each video. Okay.
Sir, but we could not download this video, sir. Problem solving session video would not download.
Actually, those videos are from YouTube. You can
Yes, sir.
watch
Only
there.
see the. Oh, yes, sir. Okay.
YouTube videos we cannot download. I mean, we can download offline, but not away from that application.
Yes, sir.
Okay, let me
sir if
post.
we are having any n cross n positive matrix
Okay.
so eigenvector for an eigenvalue
Yes.
suppose lambda is the eigenvalue which is not belongs to okay got it can be positive eigenvector for an eigenvalue which is not belongs to spectral radius can be positive correct
Yes, it can be
got it
positive. Yeah.
it
So
can be
for this,
And
we
sir,
have. Yes, please.
one more thing at 5th of September we have exam of this course so if we have any doubts in these 4 5 days can we ask because there is no option to ask to someone and get
Okay.
this one.
Okay. If you have
If
many
we have
problem,
to
if
divide
you have
na,
yeah, if you
yes,
have many doubts, so we can arrange one more class in next week. If you have
Yes,
only
sir. Yes, sir. That would be
before
great,
next
sir.
if
before
You
next week
arrange on
we have
Friday, sir.
yes sir that will be
Friday,
great on 23rd or maybe
actually
Yeah.
24th.
the timing should be convenient for
Saturday would
everybody.
be late. So Friday is very good, sir. Ideal.
Yes, sir. Friday we can.
Actually, the timing should be convenient to everybody. So, is it
The
better
same
next
as
week?
evening.
Sir,
Same Friday.
you just keep at any time, sir. We will come. We will attend.
Some comments. How the
MCQ,
questions will be,
yes.
sir?
Question paper is based on MCQ.
That I don't know actually. Yeah,
No,
question. Yeah,
don't say, sir.
yeah. No, the questions will be MCQs only. Yes, 4 options will be there. You have to choose one option for each.
Sir, how many marks is
Ah,
how what is the weightage of that exam? Because this is my first course on NPTEL.
yeah, but I have no idea about that. But the problems will be MCQs only. That much I know only.
Like assignment type.
No, there can be more problems. Maybe 25 or 50.
50 questions because this is a 3 hour question.
Yeah,
Question
8
answer.
week course. Yes. Okay, you
50
tell me.
problems can be covered by 2 marks.
I have no idea about how it can be the question paper. If you want, I can find and I inform you in next class. Okay, first tell me that when we will meet again. Friday or next Tuesday?
Sir, next Tuesday is this one. Our exam will be over.
Yes,
Oh,
sir. We have
The
exam
exam
on
is on
20.
Sunday only, sir.
this Sunday. Okay, okay.
Yeah, this Sunday only.
Okay,
So
then we can
Friday
meet.
is better.
Okay,
Friday is fine, sir. Friday is fine.
Friday,
Coming Friday.
Friday 6 to 7.
6 to
Sir,
7.
that
But
SVD you explain again, sir, singular value decomposition on Friday.
which one?
SVD, singular value
SVD.
decomposition. That
Okay.
null space, column space, something and all they say no there.
Yes.
You explain that, sir.
Okay.
Okay, sir. Thank you. No need for
Okay.
this question. We will do it. We will do on our own.
Okay. But anyway, I have to. Okay. Actually, time is over. Okay.
It's okay, sir. Thank you. Thank you very much, sir. It
Okay.
was very helpful for us.
Yeah. Okay. Thank you.
Thank you, sir. Thank you.
Okay, thank you very much, sir.
Okay.